So let me see what is not a function. That was a special procedure involved, such as a vertical line test. So if you have a graph of a relationship in between letter X in so-called domain and letter Y, which is always called range, then there'll be a few graphs here on the picture that are not functions. So what are those? Well, looks like the weekly thing that we had in 39 and exercise 38, as well as exercise 41. So these three are not graphs of functions because we can always find a vertical line that will cross them at more than one place. And the vertical line here will be the line itself, because it just coincides with that vertical line with the graph, and there are so many intersections. We have there infinitely many of them. And same with problem 41. So these three circled are not functions, and the rest is. So we're going to deal with various graphs. That's basically what the section was talking about. And it started to introduce you the fact that instead of y equals to this equation, now since it's a function, we put f and x in the parentheses. And other than that, it's just the same exact procedure if you want to graph. So just graph instead of function y, you put f of x. But other than that, it's the same thing. So if you decide to graph, let's say exercise number 31, then the graph will be coming out from the picture of a negative x squared. We already saw this, right? Minus makes parabola to open downwards. And then 6 added to it. So if I treat this as a y is equal to negative x squared and 6 added to it, then the graph of what I just produced above will be shifted by 6 units upwards. So the parabola that opens down will be now having its vertex. That's the point, the one on the top called vertex at point 6, because it's moved up by 6, because we added 6. And there is absolutely no difference. If you put y or f of x, that's the same thing. So they don't show here anything new, but just want us to get used to the fact that y could be replaced with f of x, and that's fine. So I guess I'm not gonna spend time with this piecewisely defined functions, but keep talking about this domain and range story today. So we saw that domain is the x coordinate and range is y coordinate, right? That was another part here. And it looks like we hear about two facts when we deal with these domains and ranges, because usually domain is everything, all the real numbers, but sometimes you need to restrict this domain by two special cases. One of them was having a square root, and the other special case was when we had denominator. And this is what should help us in graphing. So, for example, if you try problem number 36 here, that's a section 1.3, I guess that's where we stopped, right? So if you have a function, a square root extracted from x minus 2, then we want to find the domain of that function by making sure that you don't square root negative number. So whatever is inside the square root needs not to be negative. Remember the key idea, if you square root some negative number, this is not going to work. And we even tried it with a calculator. The calculator didn't like it at all. So we square root only positives, only numbers that are greater than or maybe equal to 0. So this tells me that x is greater than or equal to 2, and this is the main. Someone can say, Alex, so you say it's gonna help us graphing? Yes, because if we are to graph so-called square root function, and that's how the square root function looks like, it's like a half of parabola, square root, then having the main that starts at 2 and going to the infinity all the way to the right, our square root will be shifted 2 units to the right. So that's how I graph that function they gave me, f of x or y, if you wish, same thing, equals to a square root from x minus 2. So this is our function. And the main helped me to see how this graph behaved. Let me try one more graph with a square root in analogous format. So 45. Here's a square root that I extract from 4 plus 5x. And they decided to call this as function g of x. So is there any difference? You call it g or f? Well, it's just a name, right? Some people called Alex and some others called Felix. So, well, just a name, but the process is same. You want to find the main first. And when I see the square root, the main will be radicand, which is not negative. So this is my radicand that I put greater than or equal to 0. Please notice it's the same as in the previous problem. And now I want to solve this for x. So I put 5x is greater than or equal to -4. And then when we divide by 5 on both sides, we get -5 in denominator, right? So it's 4 divided by 5. So whatever the number is, I just put it on the number line. I say, Alex, not here, it's negative. Careful, it's on the other side because it's negative, for instance, the other side of 0. Okay, here, 4/5. And the graph now is moved all the way to the right, just like we had in the previous example. And what helps us graphing is this square root function that comes out of so-called library of functions. So this is the first case, and I even shown you why the main is so important. The case where you have square root. Let me try second case here, like a problem number 40. The exercise 40 deals with the denominator. So function f of x here has denominator, and that also bothers me. I say, Alex, there are so many things that bother you. You need to calm down. Well, I need to, but that's the second case where you have denominator. So you need to take this denominator, make sure it is not equal to 0. So we never, ever divide by 0. So that's going to throw away something from our domain. Let's see what it's going to be. So I bring this 6 over to the right side. And that means that x is not 2, right? When you divide both sides of this by 3, x is not going to be equal to 2. So what's the domain of this function? Well, we have it here. It's everything with exception of 2. So on the x-axis, there will be 1 point out. Well, in the future, we will see that it's actually the graph that deals with the function that has issue at point 2, and the graph of it is going to looks like go somehow like that. Let's see what. Well, I guess we'll spend a few sections graphing these things a little later. I'm just giving you an idea that's showing you that point 2 is out of the domain. So 2 is not included because it's so-called asymptote at that point. And everything else is included because at any point on x-axis, well, there'll be something on the function, but except for point 2 that is out, because at point 2 upwards, there is no value, no intersection with the graph, neither downwards, because the graph of function has so-called vertical asymptote in here. It's like invisible wall that function keeps getting along and gets closer and closer and closer, but never touches it. It just approaches to it as we go either down or up. But again, it's just a little flavor of what we're going to see in the future. And that's why the asymptotes, the domain is so important, because it helps us visualize how the graph is going to look like. And our goal in this class will be to graph, one of our major goals. So last time we observed that two issues are possible when you're looking at the domains. One issue when you have denominator, so denominator is not 0, and the other issue when you have a square root. So that's pretty much all this section is talking about. And now I can take a little look at word slope. So you're probably already a little bit familiar with this word. I hope you heard this slope story before. And slope is a number which is multiplied by x when you deal with a line. So let me get a line and find its slope. In fact, here's the very popular way to have a slope, because it's helpful little formula. That's how most lines are being produced. They like to isolate y. That's not surprising. We always try to isolate y, right? Find what y is equal, and that is done not just for lines, but for parabolas, for every function. We try to do this. So let me get the exercises and graph some lines for you and identify their slopes. So for example, if you try to start with exercise number 13, I say, ooh, 13 is no good. Well, today is 13. Today is Friday the 13th, right? So it's exercise of the day. The exercise number 13 in the section R4, we are. Where we have equation 3x minus 4. So turns out that the line we have here, because both an x and y are just staying by themselves, the line has a slope equal to 3 according to this equation, and B is called intersection point with y-axis. So people call it as y-axis intercept. So let me graph this line. So what I can do is use my favorite little table with 2 points, because if this is a line, all I need is a pair of points, and I will use my favorite number. I guess you already know what it is. It's a 0. And next favorite is 1 instead of x. So if I try 0 to use instead of x, in this equation, the x term will go away times 3 times anything. 0 just disappears. So you get minus 4 for y. Do it again with the other number with number 1, right? So we get the 3 multiplied by 1, and then we subtract 4, and we calculate. So it's 3 minus 4, which is what? -1. And this is great. We now gonna plot those 2 points and then make a little sense of what the slope actually stands for. So here's the first point, -4, which is on the y-axis. Let me get this y-axis a little longer. It's yellow. Same. No, so here's -4, someplace here. Notice this is 0 and -4. Remember, it means that point belongs to the axis because one of its coordinates is 0, right? Next point is with coordinates +1 and -1. So this is going to be a second point that I produce here, someplace here. So I can connect them and get a graph of my line. So not surprisingly, point -4 is y-axis intercept, because that's the point my line intersects y-axis. And you can see from this formula that y-axis intercept is right here in the equation, which is -4. When you say, so Alex, you didn't have to calculate that, you just put it right away on the y-axis? Yes, you could do that. See, you have various ways to graph your lines, and it is up to you how you do this. Sometimes people actually use this intercept and a slope, and what this means is that now I can see how one can get from one point to the other, going first horizontally and then vertically. What I'm talking about is I'm moving by one step, because this is 1 here, right? By one step to the right to get to that point, and then by 3 steps up from the level of -4 to the level of -1, looks like. So this will be 3 steps up and 1 step to the right. So slope, if you ever saw this before, is called rise over run. I'm just refreshing the memories of those people that heard these words. Rise divided by run. And what they say, the rise is how far up you rise. So how you go along y-axis, so vertically. And the run is how far you go to the right or horizontally along x-axis. So if you go 1 step along x-axis, you need to rise 3 steps along y-axis. So the slope is actually 3 divided by 1, which is 3. Well, later in this class, we'll introduce word derivative, and we'll see that slope is nothing else but just derivative. But, well, here we're just refreshing memories on this, and that's why I'm not gonna really care how you graph. So we use slope or use 2 points of whatever kind you like, as long as your line is something that looks similar to what I produced, that's absolutely fine. So this week is the last day when I'm out, and next week I'll be on campus. I'll be back to campus. So if you be in the classroom, you will see me there on Wednesday, not on Monday. Monday is holiday. It's a long weekend, right? College is closed on Monday, so Wednesday I'll come on campus. We'll be in the classroom. If someone wants to be on Zoom, if you like that, it's fine with me. You can just continue on Zoom, because I'll bring the laptop and I will also have an option for you to be on Zoom. So you'll let me know how you liked this or not really or whatever. So on Wednesday, I will be on campus. Today, I think I'll give you a little break in the spirit of coming long weekend. You're probably already planning for relaxation or for something nice or not really to do over the long weekend. So I don't want to be in between of your plans and don't want to put math in there. And that's why I decided to just let you go today without a quiz a little earlier, in a spirit of coming long weekend. I think that'd be fair, right? So I'll let you go today without a quiz. So next week we'll have a quiz. We'll meet if you want in the classroom or on Zoom if you want to be there. So, but this Friday, I guess I'll let you enjoy the long weekend. So we'll continue next week. So no quiz today. I'm not going to collect the attendance. So if you want to relax, you deserve it. So I stop this recording.